All right, geometry guys, this is solving systems by substitution. They're solving systems of equations. So a couple different ways you can do it. One is by substitution, the other is by elimination. So solving for substitution, you do this. Solve one of the equations for one of the variables, so basically get a variable by itself. Substitute that expression into the other equation, solve for the remaining value, and then substitute that value back in and figure out what your first value was. So the way that works is you basically get a variable by itself, switch that in so you're only solving for one variable, and then solve it, and then put it back in and solve for the other one. So two things can happen, three things can happen, two things that happen that kind of throw a wrench in the works. If you get something to where both of them are true, so you get something like 4 equals 4, well, that's going to be true, and that's going to be true all the time. That is a mathematical true statement. That's going to be infinitely many solutions. If you're going along and solving and somehow get like -7 equals 11, well, that's never true, so you're going to end up with that being no solution. So when you look at something like this one's going to be nice and helpful because y always already equals -10. You don't have to solve for anything. That one's already there. So what I do is I leave 10x plus 2, but instead of y, I put in -10 equals 10. So 10x minus 20 equals 10. 10x equals 30. So x is going to equal 3. So my solution is going to be 3, -10. So here it's going to be a little bit tougher. Instead of, see how y is by itself right here, y equals, so y is all by itself. So I'm going to substitute that in for where y was in the top one. So I'm going to take all this and throw it in for y right there. So it's going to be 15x minus 10x minus 15 equals 30. All I did was distribute. Be careful with the signs. Make sure you keep those straight. So 5x minus 15 equals 30. Bring this over. X is going to equal 9. Now I'm not done. I got to figure out what y is. So I like to put it in back in the easy one. So 2 times 9 plus 3. So y will equal 18 plus 3. Y will equal 21. So elimination. Elimination, remember, that's where you're going to add the two or subtract the two equations together, but only once you get the same thing in front of one of the variables. So you're going to look for how can I get the same thing in front of both variables, so like in 2 and -2 or a 4 and -4 or something like that. Then you're going to add the equations together so it eliminates, and then you're going to solve for the remaining one, then plug it back in and solve for the previous one. So here, right away, I'm noticing that I've got +5 and -5y. That's what I want. So I'm going to add these two things together. Because watch what will happen. 4x and 3x is 7x. 5y plus a -5y is 0. 6 plus 8 is going to be 14. So when I solve that, x is going to be 2. Okay? Nice and easy. So now substitute 2 back into either one of these. Doesn't matter which. I'll take the top one just because it's there. So that's going to be 8 plus 5y equals 6. Subtract 8, subtract 8. 5y equals -2. I get y equals -2 fifths. Just double check my work here. Looks good. All right. 3x minus 4y, 5x minus 7y. It's a little bit trickier because right now I don't have anything in front of x or y that matches. But I do have the fact that it's a -4 and it's a +7. I like to, when I have opposite signs like that, I like to kind of go after that variable just because that way I just have to add the two equations together and not subtract them. So I'm going to multiply this by 7, multiply this one by 4. So that's going to give me 21x minus 28y equals 70. This one's going to be 20x plus 28y equals 12. Now, when I add them, this is going to give me 41x. This is going to give me 0y, or just 0. So that's not going to be there. This is going to give me 82. So if I divide, x should equal 2. So now, once I figured that out, 3 times 2, 3 times 2 minus 4y equals 10. So 6 minus 4y equals 10. Subtract 6, negative 4y equals 4, y equals negative 1. So if I look at something like this, here's what I end up with. Two p plus q equals 18, 5p minus q equals 11. So 2p plus 3q equals 18. 5p minus q equals 11. So I've got plus 3q and minus q. I like that, so I'm going to keep it that way. I'm going to multiply this bottom one by 3. So I'm going to have 15p minus 3q equals 33. On the top, I've still got 2p, 3q, and 18. So when I add these two together, I get 17p, then 18 and 33 is going to be 51. A little division, and I get p to be 3. So p equals 3. Substitute it back in. I like to go 5p minus q equals 11. I'll substitute it back in there. So that's 5 times 3 minus q equals 11. So 15 minus q equals 11. So negative q equals negative 4. So q is just going to equal 4. There's my answer. All right, let's get after this. Try some of these, mess around with them. You might make mistakes, that's okay. Just mess around with it until you figure it out.